Hello everyone! It's almost the end of the year, so it's the moment for a digital Christmas card. I wish everyone a very nice Christmas and a very good New Year. So I hope to see you next year. That was it. No, of course not. In this video, I will tell you about my digital Christmas card. How did I make it and how can you make it also? I have used to make this PCB EasyEDA. I will let you see how I did it. I've soldered the smallest components with very cheap tools and I will let you see how I did it. So you can make my Christmas card also. On my GitHub page you can find all necessary files to make my Christmas card for by you at home. But of course, if you see the whole video, you don't need that files because you can make your own digital Christmas card for your friends and family. I am Brendan Koster and this is Brendan in Tech. Let's make this thing! First important decision that you have to make if you want to make a PCB is which program do you use. Most times I use KiCad or EasyEDA. KiCad is quite professional. You have very nice looking and precise measured PCBs. Only it's a little bit hard to use it. So EasyEDA is easy to use, especially for beginners. It has a very big library of components, so you don't have to look for components and footprints on the internet. And there is an auto-root function that makes it very easy to track your traces, what in KiCad you have to do by yourself. It is smart to first order your components before you make a drawing of your PCB. So I've ordered a ATtiny 1616 from Reichelt. That was the most cheapest chip at the moment that was capable of running NeoPixel LEDs. Also I have ordered NeoPixel LEDs in 3 different sizes and a few small components like a button, a PPTC or self-resetting fuse, a pull-up resistor and some capacitor to decouple the ATtiny 1616. First step by ordering a PCB is making a scheme. In this scheme, you put in all components and connect them with each other. It is here not important that they are at the right place, only that they are right connected with each other. So I start by looking in the library for the ATtiny 1616 chip and I connect VCC and ground and also flag 3 of these outputs for the NeoPixel strings. Then I search again in the library for the NeoPixel LEDs, the WS2812B, and I have this in 3 different sizes, the 5050, the 3535 and the 1010. For these NeoPixels, I connect VCC and ground and also flag the D-in pin with the same flag as I give to the pins of the ATtiny 1616. Now I have all components with 4 or more pins in the scheme. It's time to go to the PCB. For this I can click on Design and Update PCB and I get the question if I want to make a new PCB and I click on Yes. In the PCB viewer, I see the footprints of all components and I can equalize them with pictures and other things I found at the website of the sellers from the components. All components seem to be correct, so that's nice. I can put them in place. Earlier I made a drawing of a Christmas tree in EasyEDA. I copied that to this file and I put the first lights in that Christmas tree. Ah, shame. As you can see, my components now are too big for this earlier drawing. So I make a rectangle 10 by 10 centimeters and put the lights in there and use the earlier drawing as example for how to draw a Christmas tree. With all components in place, it is time to go back to the scheme and add more components. So in total I will add 6 neopixel lights of 50-50 and 7 neopixel lights of the 1010 and the 3535. Because this takes a lot of time, I will speed up a lot and skip some parts so you can see fast the result. Now, with all NeoPixel lights in place, I will start the auto router to see how everything will connect. After I label also the UPDI, so I can make a pad for it on the back of the PCB. Also, I make a pad for the VCC and ground, so I can connect that later to power and to program this Christmas card. Another thing is that I choose other pins to flag. This is to have them on a better spot and to leave one pin between, so the chances at a solder bridge are very low. VCC and ground are beside each other, so there I have no choice, but all others are with a spare pin between. Now it's time for the last small components. A capacitor, a button, a pull-up resistor and a PPTC. That last one is in fact a self-resetting fuse. Very important. To make it easier to connect if I have no shorts, I also break out the other pins I use on the back. So the three pins for the three NeoPixel strings and the one pin for the button. To connect everything in real, I've decided to draw my own tracks in the PCB. This is because my components are very small and the outer router cannot deal with it quite good. But if you have slightly bigger components or more space on your PCB, I think the outer router, and I know it is a very good thing in EasyEDA. When all components are in place, it's time to write some text to it because this is a Christmas card and without text it's no card. Writing text is very easy. You can click on the T. I write fijne feestdagen en de allerbeste wensen voor het nieuwe jaar. That meant nice holidays and the best wishes for the new year. Of course, I add my logo. I copied it from another PCB And I remove the technical text, like which components are where, because that's have nothing to do on a Christmas card. Now I'm glad with the result. I've added a few pictures, sorry, I don't record it, but it's now time to make my PCBs real. By file, you can click on generate Gerber files. When you do this, you can also click in the pop-up on generate Gerbers. Then you generate a zip file in your download folder, and in that zip file is all information a PCB manufacturer needs to make PCBs for you. So I sent this file to a PCB manufacturer, and now we can solder it. Soldering at this small scale asks for a different approach than soldering with a soldering iron. I mix soldering paste and flux in around 1 part soldering paste and 2 parts flux, and I add this to every pad on the PCB. The smallest components, like the resistor, the tiny chip, and the smallest neopixel LEDs, are so small that it is for me not possible to put it only on the pads, and yes, I have to put it on all pads in once. Because of the surface tension and that I have dilated the soldering paste, the chances on soldering bridges are reduced. So I think this have to be going good. And I've done it before, so it goes good. With the soldering paste in place, it's time to place the components. The smallest NeoPixel LEDs are so small I can't see real good how I have to put them. So I put them in place, and later on my microscope I turn it good. I place all components except for the button. If I put the button on it before, then there will melt something in it and the button don't work good anymore. Under my microscope, I can see how the smallest components are placed, and I can turn them right. You see, when I do this, there comes a little bit of soldering paste on my pin set, and that will make it that components will stick on it, and that's not fun, but it's workable. Also, too hard to see without microscope is how I place the tiny chip. So I place them right, also under the microscope. When all components are in place, it is time for soldering. Therefore, I use my cheap and small, a little bit too small, heat pad. By soldering this way, I use the surface tension to snap the components at the right place. It most time works. Sometimes the surface tension will snap the components in a little bit different spots, and then I have to use my pin set to put them in the right spot. This is for the smallest components, but also for the less small components and of course for the 80 tiny chip. The last soldering step is to put the button in place. Now we can program the Christmas cards. When you do not have installed the new 80 tiny chips, you need the board manager. For installing this board manager, you go to File, Preferences, then this button, and you can add this last line. I will put it in the description or on my GitHub, so just what's easier. Click on OK, and now you go to Tools, Board Managers, and search for Megatiny. I've installed it already, but if you do not, you can install it here. For programming the ATtiny 1616, you need a programmer. You can buy a very expensive programmer, but also use your Arduino Uno, or a clone like I have, as programmer. For this, you need to install gtech to UPDI on your Arduino Uno. This you can find on this GitHub page. Link in description. For installing this, you click on Code and Download. Now you have the file as a zip. In the zip map, you find source. Copy this folder outside the zip file and rename it to the same name as the Arduino file in it, gtech to UPDI. Open the gtech to UPDI Arduino file, and you see there are a lot of files inside. The first file is empty, that's no problem. You can upload this code to your Arduino Uno, and you have made the gtech to UPDI programmer. However, you have to do some hardware steps. We need for this our Arduino Uno with the software. We need also a capacitor, one alco, a resistor 4.7 kilo ohm, a small piece of breadboard make it easier, a jumper wire, and who knows, more jumper wires also easy. We start connected with the capacitor between ground and reset. Look to the minus point, this have to be the ground, and the other side have to be in reset. This is to not resetting the Arduino when you're uploading your code, but to resetting the ATtiny 1616. We put the jumper wire between pin 6 of the Arduino and one spot of the breadboard. We use the resistor between this spot on the breadboard and another spot on the breadboard. Now we have the other jumper cables. We put here the white in 5V and the black one in ground. I'm lost my capacitor. Now I put them in later. So not an easy job. So he's in. And the blue wire to the other side of the resistor in the breadboard. Now we have completed our UPDI programmer. By putting the other side of the jumper wires to the back side of our Christmas card, we can program it. For programming, you have to choose by Tools, Board, Megatinycore for the 1616. Now you have by chip choose ATtiny 1616. And last is below by programmer choose for gtech to UPDI. When you have done that all, you can put the end of the jumper wires in the right order to the back of the Christmas cards and press on upload. Now, after a few seconds, you see the lights turn on. Nice! Let's look if all lights go on. Now, turn the Christmas card around and put also the jumper wires to the back. Now we see not all lights go on. This is no big problem. Because of the structure, most times between the last light that goes on and the first that not goes on, there is a missing link. So putting the Christmas card on the heat pads and shuffle a little bit with that two lights will fix it
Powering the
most
Christmas
times.
card is quite easy. On the back we have made the pads. There is min that have to be connected to ground and plus that have to be connected to 4.5, 5 or 6 volt. This Christmas card consumes around 24 till 29 milliamperes. That meant that if you connect it to a LR44 battery, you have to need 3 and it lasts around 5 hours. Do you connect it with the CR2033, you have around 10 hours lights. If you use AAA batteries, you have 30 hours of Christmas lights. And last, if you use 3 AA batteries, you have 100 hours of fun. So choose what you want to do. Another option is to connect a USB port to the back of the Christmas card. That's also quite easy. Most USB ports, USB Type C, are not capable to dealing with power delivery, so you need a cable USB A till USB C to power the Christmas card. And now we're arrived by the end of the video. I hope you enjoyed and maybe you learned something from it. I wish you all a very Merry Christmas and a Happy New Year. I should say, this was Brendan in Tech and until the next video. Goodbye.